EasyCam offers feature recognition. Pick a pocket and EasyCam assigns all your machining strategies. The same is true for all other part features. We could also call it knowledge-based machining. Just point and click and you get the coolant where you need it, depth of cut is taken care of, and any other information needing an explanation. All that information is stored in a parts feature. Well, EasyCam is just taking it a step further. Tool-based machining. What if we were to eliminate a few extra steps? EasyCam is now capable of putting the focus on the tool that's in your hand and not the virtual tool recommended by the CAM software, so we can eliminate any editing. With tool-based machining, EasyCam stores all your settings in the selected tool. Simply point and click, and the knowledge-based technology takes over. You can edit values, but that is mostly on the fly, meaning you're not starting from scratch. So let's pause for a moment. You can import a model, automatically create machining boundaries, called curves, and skip over any instructions on how the tool is used. Amazing! Pushing the limits every time keeps you on the cutting edge, and to do just that, all you had to do is come up with a tool list. Just think of all the applications that apply to tool-based machining. Once we walk through the setup, I think you'll find it easy to comprehend. Feature recognition has its place, and so will tool-based machining. We're either referencing a previous tool with one, or we are taking control and using what feels good for that day. Your knowledge-based information is stored in EasyCam's directory. First, you create folders you can identify with. I used F for feature, N for tool number, and T for the basic tool used. I even went as far as separating the tools out per machine. Each tool has its own rhythm depending on where it is cutting. I'm going to show you how to add a tool to your library and then how to apply it. Then you go into EasyCam, and then that half-inch tool, we're going to start with a contour. I'll go to Advanced. We'll use tool number 5 for that half-inch tool. Change this to carbide, and then calculate our feeds and speed. Go under cycle data, and when we're contouring, maybe we want to take a rough pass and a finished pass, so we'll leave 20 thousandths and we'll take that in 10 thousandths increments. We'll use a lead in and lead out, and we go to File, Save As, and we're going to call this Contour. Open a new EasyCam document. This half-inch tool can also pocket. Set up your pocketing parameters. I'll change the step over to 30% as an example. Then save this as a pocket. And you could do the same thing if your tool can handle facing and so forth. Open your part document. Use feature recognition. We'll machine this pocket, represented by a red curve. Go to our Chris half-inch directory, and for the methods, we've created a contour and a pocket for that tool. Hit Update Work Steps. We'll verify our machining. We'll check our work step to see if we're using tool 5 on a 30% step over. Tool 5, 30%. Now we'll do the outside contour. I'm going to finish this part using the tools that I've added to the library earlier. Notice I've added comments to the work steps. This just makes it easier to use tool-based machining. And because I've used Save As Rule, I do not have to go into category and method. It automatically knows that that hole is for a 1/4 inch drill. Just getting a model from your customer isn't enough. It's knowing what to do with it. EasyCam steps a little further into the technology you need to make your parts faster, easier, and with less mistakes. Tool-based machining requires less of a programmer.